go over our chapter 1.3 of our textbook, adding real numbers as well as arithmetic sequences. So there are 4 types of adding real numbers. The first type is adding 2 positive numbers. We've been doing this for quite a long time. That's something like 2 plus 3, 4 plus 9, 24 plus 27. The second is adding 2 negative numbers. This would be -2 plus -3. The third, and I've broken these two apart into 2 because it does make a difference if you start with a positive number or start with a negative number. So the first one we're going to discuss is adding a positive number and a negative number, and then lastly adding a negative number and a positive number. So 2 positive numbers. Let's think about the problem 5 plus 3. Now we know the answer is 8, but let's see what it would look like on a number line. So on a number line, I've just created a number line from -2 all the way to 9. And I'm going to start at our origin of 0, and I'm going to take our first positive number, the 5, and I'm going to move along the number line a positive 5 times. So, and then I'm going to stop. So I'm sitting at positive 5 right now. But the plus 3 means go 3 more. So 1, 2, 3. So our answer is positive 8. Okay? So we've done this before, but visually I want you to see what we're actually doing. Starting at the origin, moving up 5 units, and then 3 more units to land on 8. Let's try 2 negative numbers. And we'll just take a problem of -2 plus -4. Now, -2 means go to the left of the origin 2 spots. So there's 1, 2. So I'm starting on -2, and I'll add -4 more. So when I'm going negative, I'm going to go to the left. So 1, 2, 3, 4, and I land up on -6. Now there's another way to write this problem. -2 minus 4. Without the plus in the middle, it's still going to end up as -6. Okay, so 2 ways of writing that one. One, it's very clear that we're doing addition. The other is, well, it looks like we're doing subtraction, but subtraction is generally moving the opposite of the positive direction. So let's try a positive number and a negative number. So again, I'm going to start on the origin. I'm going to move 2 forward. And now I'm going to add a -5. But adding a -5 actually means going to the left -5 units. So let's go back 1, 2, 3, 4, 5. And our answer is 3. Okay? So I went forward 2, and then I went back 5. Here's another way of writing it. So instead of 2 plus a -5, we can say 2 minus 5. Either way, our answer is -3. Now let's try a negative number and a positive number. So the negative number comes first. So we have -4 plus 6. Here's our number line. I'm going to start on a -4, so from the origin, 1, 2, 3, 4 to the left. And then I'm going to change directions because it's the opposite sign. I'm going to go forward to the right 6. So 1, 2, 3, 4, 5, 6. The answer is positive 2. Now there's a nice, I don't want to say trick, but there's a nice pattern on how to add these up. If you have two positive numbers, you're going to add the 2 and keep the positive sign. If you have two negative numbers, you're going to add the numbers 2 and 4 and keep the negative sign. So 2 plus 4, if they were positive, it would be 6, but since they're both negative, we're going to keep the negative sign. If it's a positive and negative number, we're going to subtract the two numbers and then leave the sign of the larger of the two numbers. So in this case, 5 minus 2 is 3, but the larger number, 5, has the negative, so the answer is negative 3. And then the last one is 4 plus 6. Let's just subtract the two numbers, 6 minus 4, which is 2, and the 6 has the positive, so that our answer is positive. So again, let me reiterate, if they're the same sign, just add them and give it the sign of whatever the problem is. So if they're both positive, it's going to be positive. If it's negative, the answer is going to be negative. It's when it's the opposite sign, we actually subtract and give the sign of the larger. An arithmetic sequence is a pattern of numbers or a list of numbers in which each number changes by the same amount. So you start with one number, and then you add or take away from that number the same number. So let's say we start with 1, and we move to the next number, which is a 3. It changed by a positive 2. So each number in the sequence is going to change by a positive 2, positive 2, positive 2. So it would be 1, 3, 5, 7, 9, and so forth. So let's look at a typical sequence, 1, 2, 3, 4. And what are the numbers changing by? Well, 1 to get to 2, you added a 1. 2 to get to 3, you added a 1. 3 to get to 4, you added a 1. So there is a sequence, there's a pattern. So we add the 1. So we know the next number is going to be 5, 6, 7. Let's take another sequence. 2, 5, 8, 11. How does it change in between each number? 2 to 5, we added 3. 5 to 8, we added 3. So we can see the pattern. So the next number should be 14. So 2 plus 3 is 5, 5 plus 3 is 8, 8 plus 3 is 11, and 11 plus 3 is 14, and so on. But we don't always have to just add. The sequence might go down in numbers. So let's think about this. 10, 4. What changed? Well, 10, to get to 4, I had to subtract 6. And let's see if that is indeed the pattern. 4 to negative 2. Well, if I subtract 4, that gives me 0, and 2 more, that is negative 6. And 2 to get to negative 8 is negative 6 more. So I can see what the pattern is. So the next number is going to be negative 8 plus a negative 6, which is negative 14. And so on. I want you to think about where you might see an arithmetic sequence out in the world. Would you see it in nature? Would you see it around your house? Would you see it? Think about like the simplest things. You have a 12-pack of sodas in your fridge. Somebody takes one, you now have 11. Somebody takes another one, you now have 10. That in itself is a sequence. So think about how these things work with the real world.